SDG labs! Ah! What up, dudes? We're going to be covering a new topic today. What up, dudes? We're going to be covering a new topic today. What up, dudes? We're going to be covering a new topic today. We're going to be covering the physics of force. Ow. That hurt. Alright, anyway, the one equation, last quarter we spent our lives on 4 equations, and that pretty much was it. We also learned a little bit of trigonometry. With this chapter, we're going to learn this one equation. It's going to be F equals ma. That literally is it. Force is equal to mass times acceleration. Let me tell you a little bit about this thing. Sometimes you're going to see this symbol out in front. That just means the sum of forces is equal to mass times acceleration. What I mean by that is if you add up all of the forces, it's going to equal the mass times acceleration. This is really kind of based off of Newton's second law. This looks simple, and it actually is kind of not that bad. But I'll be honest with you, last quarter, actually I think it was this summer, I took a course in civil engineering. It was called CEE 381. It was like 381. That's the level of the course, and it was civil engineering. And all we learned was this. We learned this over and over and over and over and over again. And we applied it to almost every single situation. I almost feel like, and I can't vouch for this because I'm not an engineer. I haven't taken every engineering course under the sun. But it almost feels like if you want to be an engineer, if you learn this equation right here, actually, to be honest with you, all we covered was this. We let A equal 0, and then we basically just solved this problem all day and all night. But if you want to be an engineer, even if you want to be if you want to be an engineer, this equation seems to me as something very important for you folks to learn. All right, let's break it down. See this symbol right here? That is a Greek letter sigma. It's a capital sigma. The lowercase looks like a little, I don't know, like it almost looks kind of like a circle with like a flipped up hair kind of deal. All right. So that's an uppercase sigma, and it just means to add up all of the forces. And it means to add up all of the things that you have. So if I have like sigma F, it means add up all the forces. If I had sigma M, it would mean add up all the masses. If I had sigma, sigma N, where N represents numbers, it would mean add up all the numbers. So it just means add up whatever it has. This right here is the mass, this right here is the acceleration. Units for the mass that we usually use is in kilograms. The acceleration is in meters per second squared. And if you have the specific units of kilograms and meters per second squared, then we've given that a specific, instead of writing kilograms times meters per second squared every single time, we've given that a special name, and in fact we've named it after the person who kind of came up with this concept, so it's called a Newton. So that is a measurement of force in scientific units. Now, just like there's meters and feet, there's the, I don't really want to say it, but the dumb way to do it, which would be the English standard version. Even the English don't use the English standard version. But anyway, this could be a very confusing point. But a lot of times when people ask, well, what's the difference between your weight and your mass? One of the equations I give them is I say, your weight is a force. So your weight is equal to mass times acceleration because it's a force, and the acceleration that we're specifically talking about is a very specific acceleration. It's 9.8 meters per second squared, which is gravity. So your weight is equal to mass times gravity. It's really just a different variation of this equation. It's just we're giving the force a very specific name called weight. And obviously you can see that weight is not equal to mass. Weight and mass are not the exact same thing. Because if weight were equal to mass, then it would be weight is equal to mass, no g. But the fact of the matter is, I multiply the mass times g, and then I get weight. Means that they're different, but they are very closely related to each other. Your mass is kilograms. Your gravity is meters per second squared. Your weight is measured in newtons, actually. What I think is kind of crazy is if somebody asks you how much do you weigh and you're in America, you would say 130 pounds or something like that. Pounds is not your mass. Pounds is the force that you apply to the ground. LBS. So the scientific community use newtons, the English or the Americans use pounds. What is the mass of in the American version? Well, I don't think you've ever heard of it. Well, what is the acceleration? I'm sure you've heard of this. This is in feet per second squared. Because at least we were smart enough to use the same time units. We would use different, meters or feet. This one's interesting. The mass in English units is called slugs. Now, to be honest with you, I've never ever heard of any engineer actually using slugs. But literally, that's kind of what that's what the mass is. You always talk about pounds. What's crazy about it is if I were to ask a French person how much do they weigh, they would give me the kilograms. And if I were to ask an American how much do they weigh, they would give me the pounds. Now, technically, I think that the Americans are right on this one, because how much do you weigh implies how much force are you exerting on the ground, which should be a measurement of this. Technically, the French should give me their weight in newtons, but they give me their mass. Okay, all right, fine. I could see how people could get confused between those two things, because someone would say, oh, I weigh 50 kilograms, and somebody else would say, oh, I weigh 120 pounds. Well, this is saying, I guess when they say, oh, I weigh 50 kilograms, you should say, wait, I didn't ask for your mass, I asked for your weight. You know what I think is kind of fun is, if you go to the moon, gravity is no longer just 9.8 meters per second squared. Your new weight, let's call it weight with a little m on the bottom, is equal to your mass times gravity with an m on the bottom. Your gravity with an m on the bottom is actually a quarter of what gravity over here is. So you would weigh a quarter of your weight, but your mass wouldn't be different. Your mass is an internal property of who you are. It depends on your density, and it depends on how much of you there is. Your weight depends not only on your mass, but on gravity as well. So if I change gravity, my weight can change. If you want to go on the ultra slim fast plan, go to the moon. You'll weigh less. Your mass won't be any different. You'll weigh less though. Shoots, bro. Up out.